We're now going to solve exponential equations. Equations that involve terms of the form a to the x power, where a is greater than 0 and a not equal to 1, are often referred to as exponential equations. Such equations can sometimes be solved by applying the laws of exponents in the following equation. If a to the u equals a to the v, then u equals v. What this really means is that if you have two expressions that are equal to each other and they have a common base, then the exponents must be equal to each other. Let's look at an application of this particular situation. We have an equation, 3 to the x plus 1 power equals 81. This is an exponential equation because it involves an expression in the form a to the x power. What we're going to try and do is take the right-hand side of the equation and write it so that it also has a base of 3. Can 81 be written as 3 to some power? The answer is yes. 81 is 3 to the 4th power. Now, because I have the same base, I can set the exponents equal to each other. The result that I obtain is that x plus 1 equals 4. Subtracting 1 from both sides of the equation, we get that x equals 3. So the solution set to this particular equation is 3.
Now that we've solved this exponential equation algebraically, let's see how we can solve this using a graphing utility. We want to solve the equation 3 to the x plus 1 equals 81. We have two options for solving equations on our calculator. We can use the zero feature or the intersect feature. Since we have two expressions, one on each side of the equal sign and neither is 0, we're going to opt for the intersection method. So we're going to let the left side be y1, and we'll let the right side be y2. We'll go to our graphing calculator and enter these two values for y in, the two expressions. So in y1, we're going to put 3. We need to raise it to a power, so we use our caret button. It's important here to group that power in parentheses. So we'll open parentheses, do x plus 1, and then close parentheses. So we have the left side of our equation in y1, it's 3 to the x plus 1 power. Hit enter, and in y2 we put in the value 81, that's the right side of our equation. And then we go ahead and graph that, but before we graph it, we need to set up our window using information that we know. We know that the y value we're looking for is going to be 81 because the right-hand side was equal to 81. We also know from doing this algebraically that the solution, or the x value, will be 3, so we can use those pieces of information to limit our window settings. So for x min, we're going to start at 0, and we're going to use x max at 4, and we'll scale by 1. For y min, we know we need the y value to be 81, so we're going to surround 81. We might go from 0 to 160. So we'll use a y min of 0 and a y max of 60. It puts 81 about in the middle. And here we'll scale by 10. And let's graph that. Here we have the graph of 3 to the x plus 1 power, and then the graph of 81. And we're looking for the intersection point. So to find the intersection point, we go to our calc menu. So we'll do second and the trace key. We want to use option 5 for intersect. First curve is y1, so we'll just press enter. Second curve is y2, just press enter again. And for our guess, we can scroll to that point of intersection. Now we know that the x value will be 3 from doing this algebraically, but we'll go through this process assuming we don't know that. So we get close to that intersection point, hit enter. We find the intersection point is 381. Drag that over. Now when finding the intersection point, the x-coordinate of the intersection point is the solution to our equation. So the solution to our equation is x equal to 3, which agrees with our algebraic solution.